Good morning. This is the last lesson of Extended Algebra 1B, and it actually happens to be a 4.0 lesson, so I know that a lot of people probably won't get here. But today we're going to talk about applications of quadratic functions and using graphs that are in standard form to solve application problems. I have this really zoomed in, so hopefully we can see really well. The height and feet of a basketball that is thrown can be modeled by the function f of x equals negative 16x squared plus 32x, where x is the time in seconds after it is thrown. We're going to graph the function. Okay, so this is actually in standard form. Standard form, you might have a plus 0 there for a c. But we are going to find the axis of symmetry by doing the opposite of b over 2 times a, which gives us positive 1. We're going to plug that in like we did in 10 by 4, excuse me, and see what we get. We actually get 16. So our vertex is at the point 1, 16. Let's sketch that and see what happens. We are going to go ahead and plot our point at 1, 16. Oops. And then I'm actually going to draw my line in for my axis of symmetry because that's going to make it easier to graph. And we're going to make a table like we did. So let's go ahead and make a table in here. And we're going to put our vertex on top. So I'm going to do my x's and my y's. My vertex is 116. I'm going to try 2 and 3. And I'm going to go ahead and just plug those in my calculator. So I'm going to do negative 16 times 2 squared plus 32 times 2 and hit enter. And I actually get 0 for an answer there. So I'm not going to go ahead and plug in 3 because what this is actually showing, reflect this, is that the path of the ball goes from the ground. I have to go from the top down. Very good. Up to a height of 16 feet and then back down to the ground. We're actually going to use that to answer questions, and I'm going to zoom out so you can see that. Maybe zoom in a little bit. But the maximum height here ends up being 16 feet. Make that a little bit bigger for you. Okay. It takes 1 second to reach that maximum height. And if we look at our graph, the ball starts on the ground, reaches its maximum height, and hits the ground again at 2 seconds. So it's in the air for 2 seconds. Okay, our y-intercept is 0, 0, and that represents the fact that the ball starts on the ground. A little bit smaller now so that we can see better. And then reasonable domain, x has to be between 0. Let's do an equation here. X has to be between 0 and 2 for our domain. Definitely didn't hit pi there, did I? And those are the applications of these problems. Let's look at another one, and then you can go ahead and try the practice problems. And I'm going to zoom in again just to help us see the equation better. As Molly dives into her pool, her height and feet above the water can be modeled by the function negative 16x squared plus 16x plus 12, where x is the time in seconds after she begins diving. We are going to again start by finding the opposite of b over 2a. So negative 16 divided by 2 times negative 16 actually gives us a positive 1/2 or 0.5. So if I were to draw my axis of symmetry in, I'm also going to create a table here. My axis of symmetry is at 1/2. Helps if I make it a nice straight line. And then I'm going to go ahead and plug in more values. So I can plug 1/2 in. So I'm going to do negative 16 times 1/2 squared plus 16 times 1/2 plus 12. And I'm going to type that in my calculator. You can use 0.5 instead of 1/2 if you'd like. So when I type that in my calculator, I get 16. So that's my vertex. I'm going to go one step to the next whole number. So I'm going to plug in 1, and then I'm also going to plug in 2 and see what happens. So I'm going to do 1 first. And I get 12 for an answer. So I have the point 1, 12. And then when I plug in 2, I get negative 20, which you notice won't fit on the graph. It's like way down here, okay? So keep that in mind. We can reflect this here so that we have our starting height, and then our parabola looks like this. I apologize for the squiggly lines. Hopefully yours is a little bit more straight than that. So notice that in this case, if you think of 0 as the pool, she actually started at 12 feet, jumped up in the air, and then came back down and hit the water, hopefully gracefully, somewhere between 1 and 2 seconds. So let's go ahead and see if we can do this and answer the questions. So maximum height, again, ended up being 16 feet. And it took her half a second to get there, so 0.5 seconds. She hit the water, we're going to say at 1.5 seconds. I know it's not exact, but it's good. My y-intercept is the point 0, 12, and that is her starting height. And then her domain, the domain is going to go from 0, because we can't have negative time, to, we'll say 1.5 this time. Okay, and that's all you're doing for application problems. Have fun. Again, this is a 4.0, so you have some freedom on how you show us that you understand how to apply these. Create a problem of your own, make a video, especially if those of you who are interested in basketball, look at shooting free throws or your arc on your shot, and let us know what you learn. Have a great day.